Hello, I'm Adam Stuart, a network specialist at Microsoft, and one of the conversations we've been having in our team more and more often over the past few years is around SD-WAN and having that conversation in the context of a migration to cloud or use of cloud. And this two-part video series is going to replay back the main sentiment from those conversations and provide you with a framework on how to think about this. Perhaps you're early in the journey, perhaps you're in the middle of the journey. So some of the big things not to miss, and perhaps some detail on the technical side as well. So why is this happening more and more? Well, of course, customers are moving their data from the on-prem data centers into cloud, and the use of MPLS is being questioned more and more. And SD-WAN has sort of developed as the leading, let's say, bucket terminology for all of the technologies that may be used to facilitate that. So I'm going to replay back probably about 100 or so meetings worth of experience with our largest customers across EMEA over the past 3 or 4 years. I definitely noticed an uptick in the past couple of years of customers mentioning SD-WAN. Of course, one of the things that you have to get right in a network design is, well, how do I connect back to on premises, maybe for that migration period, but more often for a protracted amount of time, there's always something left behind on-prem. So you need a network strategy that connects one world to the other. In the past, the answer was always some sort of MPLS express route based connectivity, and we have those patterns and frameworks for discussing those private connectivity options embedded in our brains. But one of the emerging trends around SD-WAN is perhaps a bit newer. So providing this sort of way of thinking about it is one of the goals of this video. My colleague Heather Z in the networking team reminded me of a concept we had back at Cisco in terms of splitting out the collateral available to customers and internal staff. And this was the idea of some content focused on BDM or business decision makers and content focused on TDM, technical decision makers. And I'm going to use that framework for splitting this series on SD-WAN into two parts. So today we're going to cover more of the business angle, less into the weeds of Azure products and routing and BGP and that sort of thing, more on the why we're doing this, how to have a good conversation, how to think about it at a high level. And then next week we'll cover more of a TDM or a technical decision makers focus session where we'll zoom in on the how do I make this real? What are the tools and products that I need to use to integrate the world of SD-WAN and cloud for a successful hybrid network design. And at the core of this first session, around more the strategy and the business angle, are kind of two questions. And that is, when I'm talking to my cloud provider, how do I want to think about SD-WAN? What do I want to mention about SD-WAN? So maybe I'm talking to my Microsoft account team about my use of Azure. How should I mention to them my thinking around network transformation? And then in the opposite direction, when I'm talking to my networking vendor, whether that be an incumbent vendor that I'm going to use for SD-WAN, or it could be I'm going out to the market for new solutions around SD-WAN, how do I talk to that audience about my use of cloud? And I've seen a lot of things done right, but also a lot of things where we could improve this conversation. So if we step back and just think about this sort of very simply, what is actually happening here? What is SD-WAN and why is this sort of top of mind for people? And I like to sort of take this back to basics. we have the red box here of the on-premises data center, which has some of our apps and data still hosted in it, but more and more that business logic and business data is moving to the blue box. It's moving to cloud. And I think it's fair to say that the center of gravity for that business logic and business intent is now more inside of the blue box, certainly in the conversations that I've seen. So we've got this transition of apps and data from red to blue. And we've also still got our users. So our users are perhaps in the office, increasingly working remotely. And of course, we've still got, as well as our data centers, we've got our branch networks. And depending on what sector you're in, you may have a couple of branch networks, branch offices, or you might have thousands of branch offices. So we have geographical distance between the grey boxes, the red boxes, and the blue boxes. And how do we connect those together? Well, we have wires. We have a network choice to be made. Do we use a private network made up of private lease lines, MPLS networks, things like ExpressRoute to hand off to cloud? Do we use the wires that are available to everyone? Do we use the public internet? Right? The public internet probably connects all of these boxes that we have on the screen here, unless you have some very sort of niche scenarios around off the grid. Or do we look at this emerging trend of, well, okay, the wires in the middle might be internet, shall we say, but then I want to overlay my private network on top of the internet. And this is what we come to refer as SD-WAN. And this video is not supposed to be an educational piece around, what is SD-WAN, why should I use it? But it's good to understand at a high level, and I'll share how I've interpreted this in my head. The first point, which I think really lets the SD-WAN market be a thing, is, well, we are offsetting the risk and the nature of the internet by using software. So in the past, we might have looked at the internet and gone, okay, well, it's perhaps too unreliable. I don't get the required throughput that I need at all times. Perhaps there's some security concerns there. And to offset those design characteristics, the business looked to private networks and MPLS to do that. In the same way, SD-WAN looks to offset those risks, but rather than using isolated, dedicated physical networking, it says, okay, well, software has advanced to the point now where we can do this in software. We can use our x86 CPUs that have advanced to the point where we can process tens of gigabits per second of network traffic with advanced manipulation in boxes that we can ship to sites. So we look to, fundamentally, SD-WAN says, okay, yes, you might have a more unreliable medium in the form of the internet. Yes, it might be more insecure, but I can use software to go, give me a couple of internet pipes and I will monitor them and send traffic left and right based on the type of application. So there was some application level insights that are required to enable SD-WAN. So for example, you might send your backup traffic over sort of a cheap internet link, whereas you might send your voice traffic over a more performant direct internet access circuit. So there's a level of visibility which you get with SD-WAN appliances that you wouldn't get with traditional MPLS CPE. Now, something that happened alongside this, because of the more ubiquitous nature of software and the software innovation, at the same stage as making the software do clever things for the transport, we're able to sort of step back and go, well, is there a better way of managing wide area networks? And the answer is yes. So rather than having 100 autonomous boxes in each branch doing their own thing, we're able to separate the control plane and the data plane. So we can have the data plane pushed out to all the branches and the CPUs and the ASICs churning through the packets, but it's all being controlled by a central controller, so a software network controller, and this could be hosted in your data center, could be a SaaS service provided by the vendor, could be hosted in the cloud, but this is effectively your single point of control, which pushes your config out to all of your branches, and also provides you a single point of visibility. That single point of control and that software control / data plane separation also enables something called ZTP, or zero touch provisioning, which means that rather than having a sort of a CCIE style network engineer go out to a site and configure this very complicated autonomous box, I can ship a box to anybody at this remote site, get anybody to plug it into the power and the wide area network, and my box will come online. And as long as it can get a public IP address, it will call home and pull down its required configuration. Again, thanks to that sort of control plane, data plane split. One of the things that the ability to consume more consumer grade or internet grade circuits for my business gives me is I get more bandwidth for the same amount of money. And this could be either perhaps a factor of 2 compared to MPLS, or it could be a factor of 10 compared to MPLS. Depends on the region of the world. And this is something which in my experience is super important when you're thinking about cloud, because maybe for X amount of money per month, you might get a 10 meg MPLS circuit. For the same amount of money, you could perhaps get a 100 meg internet grade circuit. When combined with SD-WAN, lets you run your business across that network link. And why do we need more bandwidth today? Well, that's part of the cloud story, isn't it? If the distance between your users and your applications becomes further, so say you move your applications and data out of the data center into a cloud environment, you are probably going to need more bandwidth between your offices, your users, and your data center and the cloud to facilitate this cloud transformation. So part of the thing that SD-WAN does by giving you more for less is enable the cloud. A classic example of that is I was using Office 365 as an on-prem sort of hosted server client application 10, 15 years ago. My storage of documents and data was primarily LAN-based, whereas now all my data is in the cloud, and to get between my users and the data, I've got to use a network connection. So being able to pull down big files over the WAN is super important, and therefore having that bandwidth available to you is part of the cloud story from a network angle. Some of the names that you will come across, no doubt, as part of your investigation are the likes of Cisco Viptela, VMware VeloCloud, Silverpeak, who are now owned by HPE, Fortinet Barracuda, and lots of others. These are the ones that we see quite a lot. There's probably some names that I've missed off. In the next video, which will take a more technical deep dive, we'll come across some of these names again as we've done integration work with them on our platform. Okay, I do like to sort of put the brakes on with presentations like this sometimes and just step back and go, what's the big picture here? And I think it is a really good time just to say, well, do I even need a wide area network, whether it be an MPLS connection or an SD-WAN? Because certainly the medium term or the long term arc of innovation is it would be great to just build applications that can sit on the internet and the application level logic deals with the complexity. So the application is secure enough to be built internet first, So I'm perhaps doing sort of a zero trust based identity based security posture. An example of that again would be Office 365. So for Office 365, it doesn't matter where you are in the world, you log into a SaaS service and you use all the goodness of conditional access, two-factor authentication, MFA, that sort of thing. Sort of the requirement for a private network from a security point of view fades away. Similarly, if your application code can handle the performance characteristics of the internet, maybe you don't need to drop down to the network level to solve that complexity. And there's certainly a trend in various verticals which says, let's just develop any new applications for internet first topology, where maybe you say, all I want to do is have a really, really solid cloud network design based on private IPs, etc. But anything I do outside of the cloud, I deliver on a public IP. So certainly that's the long-term trend for kind of internet first based approach to the use of cloud. But in my experience, the reality is that's going to take some time to get there. The majority of enterprise customers that I work with are still going to need a wide area network, whether it be MPLS or SD-WAN, for the foreseeable future. But I do think, especially if you're working in an enterprise architecture role, it's always good to ask the challenging questions, which is, well, why are we doing this? And what does it look like in 5 years, 10 years? So let's pick up on these two questions that we asked earlier. Let's take the first one. How do I talk to my CSP about SD-WAN? And this is the one where certainly I've got the most experience recently, working for Microsoft, being on the receiving end of customer questions, being in workshops with our customers. I spend a lot of time talking to the network teams at our largest customers, responsible for cloud network designs, on-premises network designs, and naturally the topic of SD-WAN crops up. Sometimes it's customer initiated. They've come to Microsoft and said, I want to understand how Microsoft sees this world around SD-WAN. How do your products fit into that? Sometimes it's because we've sort of asked the question, what are you doing in this area? Is there anything we can do to help? My sentiment and learnings from those conversations are as follows. So one would be, have that conversation. Don't think that just because if you're going out to the market for SD-WAN, the first name you think of might not be your CSP. It might not be Microsoft. So you might say, I will have this network transformation happening over here, and I've got my cloud thing happening over here. Those two worlds will never meet. In my experience, that's a bad decision because hopefully, as we show in this two-part video series, there's a lot of overlap between those worlds. So it's definitely in your interest to join them up as soon as possible. And we're very happy to make that a reality and work with not only your internal teams, but your network vendor. Second one would be to be verbose, state the roles. What can the CSP do for you? What can the CSP not do for you? And the classic example here that I always use is, well, the thing that if you're doing an SD-WAN transformation, you're going to need a few things, aren't you? You're going to need the CPU devices, the physical devices that live in the branches in the data center, the virtual devices that live in the cloud. You're going to need the network overlay software that ties it all together. And you're also going to need the physical circuits, whether they be internet circuits or direct internet access or 5G, satellite, or even still some MPLS. You need that physical network connectivity. So for that, you're working with a network comms vendor or a circuit broker. And all of those things together make up an SD-WAN packaged offering. And from those 4 or 5 things, your CSP can not do all of that, right? So CSPs today, including Microsoft, are not SD-WAN vendors, right? We do not sell the CPE that you send to the branch. We do not sell the last mile circuits. So be obvious about that, state that, because a lot of cloud networking vendors, including Microsoft, have products such as virtual WAN, where it can be confusing. You know, where does that fit into the SD-WAN strategy? And we're going to cover that on some future technical videos. Be aware that this is mutually beneficial for everybody. So I always say it's in the customer's interest to get this network transformation right in respect to cloud, because if you don't get it right and you make it a horrible experience for your users to use the cloud, then you could have the network team being blamed for the inability of the business to transform. The opposite way around, it's in Microsoft's interest to sit down with you and make sure that we understand what you're doing with your network, so that we can suggest the right talking points to you. Because if you get your network designed wrong and you don't have good connectivity to us, that's going to impact our ability to help you work with our products to again transform your business. So it's in everyone's interest that at least during these sort of as early as possible design conversations, there's a seat around the table for the CSP in those network transformation discussions. Now, when you lay out those roles, a couple of things crop up. The most obvious one is, well, how do I attach my SD-WAN network into cloud? And that will be the primary focus of our next video. The second one, which is sometimes missed, is there's a potential use case for cloud when it comes to global network transit. What do I mean? Well, let's look at a fairly typical global SD-WAN design. Now, let's say you've got 1,000 branches, you've got 300 in the US time zone, 300 in EMEA, 300 in Asia Pacific. Typically, what's done with an SD-WAN design is you'll have your SD-WAN network in green here in the US, and these branches, they can talk direct to each other. That's fairly common. They go over sort of the local ISP, and they talk branch to branch directly without a reliance on an intermediate hub. But normally you will have a time zone hub or a central point of connectivity. And this could be like one of your CNX or your cloud edge locations or traditional data center, which might have a bigger SD-WAN CPE device. And that's generally used to go further. So this is generally used, if I want to talk from a branch in the US to a branch in EMEA, I'm probably not going to talk branch to branch directly over the internet. I'm probably going to say, well, maybe when I go long haul, I still need a perhaps something more than the internet for the sort of long range backhaul. And that's where you might have, for example, all of your hubs in the various time zones linked together with perhaps a traditional MPLS network. So you could have a hub in someone like Equinix in the US, a hub with Equinix in EMEA, and a hub with Equinix in APAC. And you could pay Equinix to use their backbone to get all around the world, so that kind of your internet is your medium here, whereas your private connectivity is used to get long haul. And that makes the SD-WAN experience a bit better. It gives you less unreliability to mitigate, which can change the requirements for your SD-WAN solution. Maybe you need less WAN acceleration, WAN buffering style capabilities. And this is a very common pattern you'll see with global enterprises. Well, the chances are, if you're watching this video, you are using cloud as well as thinking about SD-WAN, and therefore you probably already have a central hub inside of the US, EMEA, and APAC. And that hub, if you're working with Microsoft, is going to be some sort of Azure-based hub. So you might have an Azure VNet in the US, an Azure VNet in EMEA, an Azure VNet in APAC. You've got these regions built out for your users. So you have this Azure footprint already built out globally. And what I've seen is customers can use that in the same way in which they use the grey box. So you can have your hubs inside of Azure. So if I want to talk from a branch inside of the US local network to a branch inside of the APAC local network, and I want to go long haul, rather than using the grey lines of an MPLS provider, you could say, well, what value can my cloud provider bring? Right? Okay, Microsoft, I know you've got this big global network, and I know that's more reliable than the internet. How do I use that for my global transit backhaul for not only going branch to branch long haul, but maybe I want to go branch to cloud long haul. Maybe I've got an application hosted in APAC and I want to come in here like this. And there are all sorts of things we can do with Azure networking and the Microsoft backbone to facilitate that. So the point there was, not only will you want to have a conversation about attaching your SD-WAN solution to the cloud, don't forget about the global backbone that your CSP runs. Where can that add value? And also on that point, make sure that you understand how a CSP's network is built by default, because this is something else that you could leverage as a value add. So let's think about a zoomed in version of that previous scenario. I've got a branch in the US, and let's say I've got a branch in Chicago, and I want to access a application that's hosted in my data center, which happens to be moved to cloud. So I'm using Azure in Singapore. And you might think, well, how do I get from that branch over the internet to Azure Singapore? A low resolution view would be, I just go over the internet. Okay, and I've got to deal with the internet from point A to point B. So I get a very sort of 200 milliseconds use of the internet. That could be your initial impression of how that works. Well, what happens in reality when you dig into this is, by default, the Microsoft network is configured to take in traffic as soon as possible. What do I mean by that? Well, you have your branch here in the US, and you've got a user in that branch. There'll be an element of last mile provided by the ISP locally here in Chicago. And that ISP, somebody like AT&T, will take the traffic from the user and the branch on what they would deem as an internet service. And this is where the behavior of the cloud network, the Microsoft network specifically, is something that you should be aware about. The way in which we configure our network is, as long as that ISP is paired with Microsoft in an efficient way, we want to take that traffic off that ISP as soon as possible. So for example, if that ISP is in Chicago, probably we'll take that traffic off the ISP in Chicago at one of the local internet exchange points or transit points. If not, it's almost definitely somewhere else in the US, maybe on the east coast of the US, we take that traffic off the provider. So kind of the use of the internet is fairly limited. The internet is just here. When we say the internet, I mean the public internet, where there's a lot of contention and sharing of the medium. And at that point, from the US Microsoft POP all the way to the Microsoft data center in Singapore, that's almost definitely going to be on our network. And there's multiple studies, which I'll cover some of this in a future video, which show that the Microsoft network is a lot more reliable and robust than the public internet. And we should recognize this. We should understand this behavior that, hey, if I choose to put services in the cloud, there's a value add provided by the global network by default. And I can use that to my advantage when it comes to my SD-WAN design. This is referred to in the service provider world as cold potato routing. And that is the Microsoft network is treating the packets as if it's a potato that we can hold in our hands. We're not in a hurry to get rid of our traffic. We want to hold that traffic as long as possible. We're comfortable holding the potato. It's cold potato. The next learning would be, don't just have an Azure focused conversation about cloud. Like, yes, connecting it to your Azure virtual networks, that private to private communication is super important, and we'll cover a lot of the technical detail in the next video. But there's also still a public angle to your SD-WAN conversation. And this is where SD-WAN is probably going to add some value for you. So for example, if you've got a user at a branch, maybe today on your MPLS network, you're backhauling that traffic to a central data center, doing some complex filtering, and then sending it out to the internet, which adds latency to that internet breakout. One of the things that happens with SD-WAN is normally the more advanced software, more advanced visibility lets you do local breakout in a more efficient way. So for example, you should find it easier with an SD-WAN solution to implement business intent that would say something like, all of my users, if they go into Office 365, break out locally. And using all of that goodness I just showed you about how the Microsoft network takes in traffic as soon as possible, how we've got this very large presence in our edge network, you'll probably find that local breakout with services like Office 365 give the best performance. So don't forget the public conversation as well. It's an opportunity to improve that. Okay, so you sat down with Microsoft, you've had this conversation, we've got a lot of good talking points. Now let's think about the conversation that you're having with your network provider. What are some good tips there? Well, number one, kind of seems obvious, but I've seen it missed so many times. When you go out to the market for an SD-WAN solution and you stipulate your requirements, you say, I've got these many branches, this many users, I need this many circuits, I'm going for this SLA, I'm in these countries worldwide, I want to consume the service for this contract length, etc., etc. One of the things that you should make clear as day in that RFI is, by the way, I am also using these clouds. I'm in Azure and I'm using Office 365. I'm in these regions, and your solution, either a partner or a networking vendor that you propose to me, must account for that. And I want to sort of see that you understand the cloud, what is your cloud attached story, and ultimately the solution that you sell to me has to be cloud ready. It has to be sort of by default providing good connectivity to the cloud in a way in which will support my business going forward. Which leads onto this point of supportability, and this is critical. So you if you're going out for a large tender for SD-WAN, you don't want to be the person that is sort of hand cranking the cloud side customization, and you don't want to be the person, the party responsible for the nuances required to attach let's say a Cisco Viptela solution into Azure. That needs to be a approved and supported reference design by the vendor and partner that you're working with to give that level of supportability. An example of that would be let's say you have a problem with your SD-WAN and it's users can't connect into cloud. That's sort of a high level problem statement. When you ring up your network support vendor, whether it be the vendor itself or a partner, you want them to be able to have a textured, detailed conversation about cloud. You don't want them to see it as this black box, which they have no awareness of. And as I say, the same thing goes for if you're doing this in-house or if you're doing this via a partner. If you're going to a managed network provider, we want to make sure that your choice of managed network provider understands the cloud side and the SD-WAN side, and they can amalgamate that all into a single sort of homogeneous offering that will work for your business. And then the last point, I'll just call this out, but not sort of dwell on it too long, is that it's good to sort of step back and go, is this just a network transformation that's happening here? Am I just moving from an MPLS to an SD-WAN? Or am I fundamentally changing how I do security here? Because I've seen these sort of worlds overlap a lot. And this comes back to the internet first approach I talked about earlier. Am I trying to give my users a work from anywhere model as well as do SD-WAN? And this is quite hard to unpick because a lot of SD-WAN vendors are also network security vendors, and a lot of network security vendors are increasingly SD-WAN vendors. I think it's good to be explicit about the transformation that is happening. Okay, so I hope you found that useful. We covered the business angle of how to think about this transformation, why it's a good idea to involve not only your network provider, your network vendor, but also your cloud provider. And then in the next video, we're going to drop down to the next level of technical detail and address this fundamental scenario here, which is, hey, I've got this SD-WAN bubble happening over here. I sort of understand how to connect these physical branches in to my SD-WAN. And hey, I know the business is doing this cloudy stuff over here. How do I attach these two things together? How do I bridge these two things from a technical angle? So on the next video, we're going to unpack all of the different options you've got around network virtual appliances, IPsec tunnels, Azure root server, Azure virtual WAN, all of the pros and cons of all of these patterns. So if you're interested in that, I'll see you in the next video. Thank you very much.